Hi, I'm Luke. Ever wonder how these work? Central locking, external mirror adjustment, even the horn. On this vehicle, these are controlled by a system called Local Interconnect Network, or LIN. It was developed as a low-cost alternative to CAN bus for systems in a vehicle that didn't require real-time communication. It's an expansion bus. It can be used anywhere within a vehicle where maximum information and transfer is not required. The advantages of LIN is that it reduces the wiring within a vehicle, and due to its low speed, it's very reliable. LIN Bus can also be used in conjunction with the CAN bus. This is done by a network gateway. LIN Bus can also be used on systems such as rain or light sensing, external mirrors, and interior lighting systems, just to name a few. Let's check out the system in general. The LIN Bus comprises of one or more LIN masters and multiple LIN slaves. There can be up to 20 LIN buses with up to 16 slaves on each. Multiple slaves on the same bus require an individual address. Information is transmitted to and from the LIN master to the LIN slave by means of a single wire. It's a 12-volt bus that communicates at 19 kilobytes per second. Communication is initiated by the LIN master to each slave. For example, has this switch been pressed? The slave will process this request and transmit a response by adding an answer to the message. The master can now take any action necessary, depending on the response. Communication is sent periodically, meaning the master will contact each slave in a set sequence and time. An example of this would be a light sensor. The light sensor detects that it is getting dark, and the LIN master, in this case the BCM, is constantly asking the sensor if it's on or off. Let's take an in-depth look at the signal of a LIN bus. The transmitted signal consists of a square wave pattern comprising the following information. The first part of the signal is data frames in a fixed structure. It consists of a break field indicating a new incoming frame, then a sync field which is synchronized by the LIN master clock. The ID field comes next, followed by data bytes that contain the message. A checksum of the data received completes the communication. This signal is transmitted from the master to the slave. Once the message has been received, the information is sent back from the slave to the master with its response. Let's look at these components on this vehicle and go through their functions using a schematic. We'll take a look at the door with the trim removed. There's a door control unit. This is a master. Then we have the central locking button, power windows, and external mirror function. These are all slaves. This is the schematic for the driver's door control module, incorporating a driver switch panel and a window motor. Connected to the main switch panel are both rear window switches and motors. LIN is used to connect the door control unit and the main driver switch panel. The master, being the driver's door control module, is sending constant messages to the switch panel, asking whether a switch has been operated. Once a switch is operated, a message is sent back to the master indicating yes, a request has been received. From here, the door control unit initiates the power feed to the window motor, making the window raise or lower depending on the switch input. Another example would be a light sensor module, and on this vehicle, it's located on the windscreen. The LIN bus is connected between the BCM and the light sensor module. The BCM is the master, and the light sensor module is the slave. And as you can see, there are other slaves connected to the BCM. The BCM is continually asking the slaves for a reply. Once the light sensor module determines that the headlights are needed, the on request is received by the master and the BCM switches the headlights on. This is a typical pattern for a LIN bus communication. As with all bus systems, it comprises of ons and offs, or ones and zeros. In this case, either 0 volts or 12 volts. That's local interconnect network, what it is and how it works. It appears to be quite complicated, however, it's quite a simple system. With technology rapidly changing, the LIN bus system will become more common, and understanding it will help with diagnosis. And remember, keeping up to date with technology is essential in today's automotive industry. Bye for now.